Single replacement reactions. This is basically where an element gets kicked to the curb. So the way it works is you have an element and a compound listed in a reaction. The way it works is the element will replace, if it is a metal, it will replace the front of the compound, which is a metal. If it is a non-metal, it replaces the back. The first thing you have to do is check the VIP list, though. Think of the reactivity series of metals, the list, and the non-metal one as a VIP list. The only way the reaction works is if you're VIP, you have to be higher up on the list. So for example, sodium there is higher than zinc, which means sodium can take zinc's place. So in order to take someone's place, you have to be higher up on the list. So you'll be provided this on the test. You use the VIP list to figure out what happens. So like for example here, I have aluminum and H2SO4. Aluminum is a metal, so it's going to kick out the front if it works. So I come back and check in the chart. Aluminum's there. Hydrogen is there. Notice how aluminum is VIP? Yes. So what does that mean? I come back over here, and guess what? Hydrogen gets kicked to the curb. So I take what element gets kicked out. I'm going to write it right there. But remember, it's diatomic, so I bust out a 2. Plus, then I crisscross. The metal, then the non-metal. So when I come over here, aluminum is 3+, sulfate is SO4 2-. So when I crisscross it, I get Al2, parentheses, SO4, parentheses 3. From that point, you have to balance. When I look at reaction number 2, Cl. If it is a non-metal, it's going to be diatomic. In this case, non-metals would take out the back. But you have to check your list and see if chlorine is higher on your list than iodine. So if it's a diatomic, that means the diatomics are the only ones that you'll see in a single replacement reaction from a non-metal. You have to check it on the list. Cl is higher, so I gets kicked to the curb. So I write I2. That means I'm putting together, again, the metal. So I take I always write the positive one first so you don't forget. The charge on Cl is negative. Crisscross the two of them, I get KCl. That's your completed reaction. If I look at number 3, lithium and H2O. When I go back and look at it, lithium is not on this table, but it's going to be up here. Lithium's going to be high up on this table. So lithium is obviously going to be above hydrogen. So that means hydrogen gets kicked to the curb. So I write H, bust out a 2 because it's diatomic. Then I have to take lithium, the positive one, the metal, look at the charge from the periodic table. Oxygen, look at the charge from the periodic table. I cross it, I get Li2O, and then from there I balance. So if you look at the last one, you got zinc and you got HCl. When I go back to my list, H is right here, zinc is up here, so zinc is VIP. So zinc is VIP, boots out the hydrogen, I write H2. At that point now I'm taking zinc and chloride, I'm crisscrossing. So I'm going to go plus, I go Zn, which is 2+, Cl, which is -1. Again, write the positive and the negative out, then crisscross so you don't get confused. ZnCl2, and you are good to go.